So, hmm. Okay, let me know if you can hear it. Hello? Hello? Okay, I think the live has started. Not sure if the sound is okay. I'm trying different settings from previous live streams, so okay, thank you. Alright, then I'll just start it. Today it's live stream. Okay, so this is Junichiro Horikawa and this is a weekly tutorial live for Houdini. We'll call that Houdini Algorithmic. Algorithmic Live is 129th episode, and the topic for today is to create a Vellum based simulations, creating a mesh like geometry like these, and do some like cloth like simulations or paper model like simulations like these, including a tiering like you see here. Okay, so the mesh structures like these are pretty famous in digital fabrication or cloth, or in origami as well. You could see a lot of reference like these shapes, even in for laser cuttings as well, to bend the wood with those cutting lines. So I'm gonna try to use the similar structures and use it for close simulations, and additionally create a setup how you could create a tiering like these with some stresses, external stresses. Okay, and hopefully that's my goal for today, and hopefully if I have time I would want to try like different kind of cuttings, but if I have enough time. Okay, that's my plan, and should be rather simple to set up. Alright, so first thing first, I am going to create a structure like that. So the first thing I'm gonna do is to think about how I'm gonna create the base structures and convert it into a vellum cloth. Okay, in the end I'm going to convert it into a vellum cloth, so that's what I need to do. Okay, so before going into that setup, need to make sure I understand the structures very well, what I'm going to create. So if I look from the top view, I'm just going to set a cut line to a paper or a cloth, and consider this is the boundary for the cloth. And what I'm gonna create is several lines aligning like a brick. Yeah, and I'm gonna use those lines as a cutting line. Okay, and by stretching the paper in any directions, could be in this directions or could be going from the bottom to top, these cutting lines will open up and create more three-dimensional surface like these. Okay. Which you could see in many contexts, in fashion, in product designs, and fabrication, any. Right. So it's my plan. So the approach is to create this setup in Houdini first, then try to convert it into a Vellum cloth. In order to do that, you need to define how you could create this kind of setup with the mesh, right? So let's make it simple. Let's try to think it simple. If I have a hole like that, then I could probably split into a bunch of strips like that. Then you could also split the rectangular mesh into a bunch of rectangles where you have a holes and not. Do the same for the other side. And then also you would need to have bridging lines as well, which would connect to the other to the next rectangles. So in the end, you should be able to know in which direction, in which positions you need to add edges for each strips. Now I'm just gonna try that visually in Houdini. Okay. Thank you everybody for joining. I'm trying to learn Houdini, but I don't know where to start. Yeah, it's really hard software. I mean, you could do tons of things with this software, so yeah, I don't even know where to start myself as well. But since I'm not a simulation guy, just doing precision modeling, that's where I started. But a lot of people start using Houdini for simulations, I think, because the VFX industry uses Houdini a lot, I think, for like water, smoke simulations and so on. So maybe that's one things you could start out with. It's not that simple, but the result is really great. So I have just created the geometry node. Let's start by creating the grid, the base grid geometry. Right. And I'm going to create it as a single strip, just getting one strip, and just gonna copy that later in a row, in a column, as a column. So for the column, I'm gonna set it to 2, and the rows, I'm gonna set it to several high numbers. I'm gonna use these as a base grid. I mean, to be. I'm gonna use each rows or each columns or each rows as a base mesh for this geometry, so somewhere around here. So currently the width is a bit too wide, so let's make it short as well. So I think it is wise to create D square like a square shape. So let's create some expressions to do that. So by changing the number of rows, I also want to change the width of this strip correspond to the height of each row. Okay, so let's make some parameters. I'm going to open up the parameter interface, copy the rows. Yeah, I'm just gonna call it rows, and the size for the y direction, or is it the y direction? It's actually a z direction, but does this? Okay, so this is the size that I want to change or get. So how do I get it? I'll just create a float value. Okay. That. And copy the y parameter, paste it here. Right. Now having those two values, you could also estimate the value for the x by the things that I want to know is this size here. So you can have that by dividing the y by rows. So the actual size for the x could be that value. So you could copy the y, then divide it by the number of rows. Okay. And that gives you a small width strip. Right. So this is the starting point. Okay, now what I want to do next is to create a initial wave, which is necessary in order to create a ladder vellum cloth, because in order to create a hole or a cut for a vellum cloth, you kind of need to make it open for initial mesh, because if it is stick together, then it's just gonna the vellum cloth node will see the meshes being connected to each other, so it's not gonna make a hole on it. So in order to make a hole or a cut with the line or curves, you're gonna make for it, the initial mesh has to have some openings. Then later you can close it up after you have created the vellum constraints. But before making the vellum constraints, you need to have it opened. So that's what I'm gonna do next. So to do that, I'm going to make this strip like a wavy pattern, meaning if you look from the side view, I'm gonna make it something like that, right? By moving each vertices in this direction and in this direction. Okay. Then later I'm going to copy this to make to be connected with this own strip and create a whole shape like this one, like copying right here. So this will become the whole. And then for the next strip, you could copy it like this. So this area will gonna be a whole, and continue doing that until the maximum number of your choice. Okay, so to do that, let's try to move this height of each vertices based on the position, or based on the number of edges, the ID of the edges. Okay, so guess what I could do is to do this per primitive. So each primitive has its numbers, and if you showed it up, hello everybody. I just made the guide font large, so you could see there is a number, the primitive number for each meshes or primitives, and you could use those numbers to specify which primitive goes up, which primitive goes down, so on. Alright, so that's my plan. So going back to this rule, I can see that, for example, a even number mesh like this, this one, this one, this one, where the ID is 0, though maybe not. In this case, if I am oh, in this case the even number edge will be somewhere here, 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 here. Right. And if I just move those points on those even number primitive, and if the the first even number primitive goes on negative y direction, then the next one will go to the positive y. So the first thing I could do is to pick up every edge which is in the even number even primitive number. Then from that you could again get the even number edges out of those picked one, and odd number ones. And for even number you could go to the negative direction, and for the odd number you could go to the positive direction with the same value. Yeah, that should do it, I think. Let's try. So first, let's pick up the primitive where it has even number for a primitive number. So this will do it. If you calculate the modulus with 2 for a primitive number, and if the value is equal to 0, meaning if the remains is equal to 0 by dividing by 2, then you're getting those even number primitive. You can check it by setting a color to those primitive if you like. Oh, code is being deleted somehow. Primitive number modulus 2 equal to 0. Then set the color to red. Alright. Now, from here, you could get you could calculate again if these values are an odd number or even number, starting from this red one. So the first red one will be 0, 1, 2, 3, and using that number you could again calculate the similar things like this. So first of all, you need to convert the current primitive number into 0, 1, 2, 3, 4, all the red stuff. You could do that by, let's say it's index, and you can just divide the current primitive number by 2 and get the floor value. Okay, which you'll get an index value starting from 0 on the red one and goes to 1 on the next red one and 2 on the next red one. Now again, you could check that by adding this value to an attribute, adding a marker, and see if this is correct. Okay, so 0, 0, 1, 1, 2, 2. Is this 2? No, it's 0. Okay, well, doesn't matter about the white one. I just need to know the red one, so it's 0, 1, 2, 3, 4. Yeah, so that's correct. Alright. Now you can create another conditions if the index, the modulus of 2, is equal to 0, then that's a even number, and else that's an odd number. Okay, so that's one thing you could do. Or you could, if you want to go the even number to go to a positive direction, if you want to go the odd number to go to a negative positions, then you could also do something like this. Create a float value, calculate the modulus, and the value will be either 0 or 1. Okay, if it is equal to 0, then that means it's even number. If it's equal to 1, that's odd number. So if you subtract it by 0.5, you get either minus 0.5 or positive 0.5. Then multiply by 2 will give you either minus 1 or positive 1. So in this case, minus 1 is even number and plus 1 is odd number. And it's useful to have either negative 1 or positive 1 because you can just have this single value to move the red square up and down without using any conditions. Okay, now in order to move the primitive, you need to access the points on each primitive. So let's get that by using prim points. Then loop through all the points. Access to a point number for each primitive. Get the point position. Then update the point position with a y vector value. So, and since I only want to move it on y directions, you could just place value that I've created here, which is gonna be either +1 or -1, and multiply by how much you want to move. I mean, how much you want to move, the value that you choose here, it doesn't really matter what that is, because it's just the value to make the geometry open. So bigger having big value is fine, having small value is fine, unless it's big enough to make it look like it's opened up. So let's make it 0.01 and finally updating the point position with the newly updated positions. Okay, it's a bit hard to see the difference, so I'm gonna raise up. Okay, so it's now clear. That's I've just made a wavy-like pattern. Alright, so now I've created the single strip. It's time I copy these shapes and place it next to it like these, like a honeycomb pattern. Okay, I have a question. I have a comment. Can I apply C++ knowledge to Houdini FX scenes? Only Vex. You could bring C++ knowledge, but maybe not C++, but you could bring C knowledge, because you cannot create class in Vex. So I think that's a big difference. So it's pretty close to C, but it's not so well sophisticated like C++. Yeah, and you cannot use any external C++ libraries. You could for C library maybe, but yeah, it's pretty limited. So you could say the Vex is only to do the vector mathematics or linear algebra. But it's pretty enough to modify the geometry, because geometry is made with points, and you need to know mostly need to know linear algebra in order to modify the points, positions, and all the other attributes. But if you need more high, like rich functions, like if you want to implement things like external signal data or machine learning or stuff like that, you need Python or need to make a HDA using C++, which you need to compile it as a plugin, I think. So it's a lot of work. So the simplest way is to, I guess, use Python if you need to do rich functions, but it's gonna be slower than using Vex for vector expression, vector calculation. Okay, what was I? So I have made the strip. It's time. I am going to create a the rows or columns of strips. So I just want to copy this single strip on a horizontal directions, but in order to do that, in order to do it easily, might need to do few manual steps. For example, first of all, if I look at the sketch here, consider this is the first template. Now you could create the next one by making a mirror of it. And for the next strips, you could make a mirrored shape, but yeah, you could make a mirrored shape, but you kind of need to shift actually, I guess I guess I would just need to make this as a one single pair. Then after that, maybe I can just copy and paste to have all the other rows, all the other columns. Let's try that. Alright, so to do that, let's make a mirror shape. Making Y. Okay. Now I have these. I might need to move this on a Z direction. And in order to do that, I need to know how much I moved, which is this one. So probably it's better if I promote this as a parameter. So I'm gonna call this offset. Let's make this 0.1, copy this, and have origin to negative offset, so negative 0.1. Alright. Now I also want to shift this into an X direction in this case, yeah, to the right or left by the size of this width. So I could do that by where is it? This is the X size. So I can copy this here and paste it to this origin X. Oop, didn't work. Alright, so doesn't really make any difference, so I'm just gonna use transform for that. I'm gonna use transform and move it to the X direction by this amount. Oops. I kind of needed to check off this keep original so that I could only move the mirrored one. Right. Now I have two strips like that. Alright. Now I could copy this in a row. In this case, it's gonna be copied like a diagonally, but later I'm just gonna make it flat as a final step, so it doesn't really matter for now. I don't really like that the normal direction is flipped, so let's make this flip that. Alright. Okay. Alright. Now let's make this let's make this copy as a row, as a column. Okay, so in order to do that, you need to know how much you need to move in X direction, how much you need to move in Y direction, and how many points you want to have. Right. So let's just calculate that using a detail attribute, and let's make it as a point, then using copy to point soft node to place those strips to those points. Gonna use an attribute wrangle, convert it into detail. Oh, hello, Stefan. Thank you for the super chat. Appreciate it. Okay, so what was I? Create points. Now let's add another parameters such as the x size, the size for the x direction of this boundary square, the cloth. And I guess that's all I need to know. So let's copy this value and place it here. So x size will come here, promote it, connect it with the controller. Okay, and you also need to know how much you need to move in x directions, which is this width multiplied by 2. So the width is here. I can copy this. Let's have that as a parameter as well. So strip width alright, and link it. Okay, so this is the width of this size of this 2 strip, and you have the total x size which you define by yourself, and you also need to know how much you need to move in y direction. So for the next strip you want to attach this edge to here. So in total you need to move how much is it? So this is defined here. So one strip moves offset value multiplied by 2. So the total height of this strip is 0.2. So if you have 2 strips, then that will be 4 times 0.1. So let's copy this value here, and let's name it as height. Paste it here and multiply it by 4. So it'll become 0.4. Alright, now that I have enough information, let's first define how many points do I need in order to make it close to this x size. So that will be number of strips, strip pair, which could be calculated by dividing x size by the strip width. Right, and make it as an integer. I'm gonna round it up with the rint. Alright, so now that I have a number of strips, I could use a loop to create the specific number of points. Now let's make a point. Before doing that, let's define the position of the center of the strip. So x will be related to this width, So let's copy here, multiply by I. And then y will be a strip height multiply by I. For the z, nothing. 0 is fine. Then let's create a point. Okay, where is it? Okay, I might need to make it on negative y direction, so I'll make the y value negative, like that. Okay, now let's try copying the strip to those point position. Let's see if it is being connected. Okay, yeah, it does. So right now it doesn't really look flat, but that's fine for now. We're gonna fix this later. Okay, so I mean, if you don't like being like a wall, you could modify the height right here a little bit. Let's do something like that, shall we? Something is wrong here. Something is wrong here. Let me check. Yeah, something is wrong. It's duplicated. Maybe I forgot to multiply the width here by 2 when I move this. Yeah, might need to multiply it by 2. There you go. Okay, that looks fine. Oh, okay. Okay. Okay, save this, and it's time I set up Vellum shape. Okay, so first I am going to make it fused at this point so that I can only connect the points which are touching right now, right? Then at this point I can reset the height to 0 so that it will become flat, meaning I'm just going to update the y value to 0, which gonna make it flat, but actually it has an opening. The cuts, if you later open it up, it'll still have these cut openings, right? So and that's my plan. And okay, anything else I need to do now? And also, let me think what I need to do now. Okay, I'm also going to, before making this reset to 0, I'm going to remember this original height because it's gonna be useful that some of the points are being connected, some of the points are being separated. So, which can be used to define it as a random seed or something like that later. Okay, so I'm gonna use the cop rest position to remember the current state. Alright, like that. I have a question. Why do you need to set a different y for the copies? Thanks for the listen, truly appreciate. Why do you need to set the different y for the copies? Well, just to connect these edges in order to open up these holes for our cut lines. So that's what I need, why I need it to change the y direction, the y positions for each point. Okay, and after that I have fused it so that if the edge is being connected, you only have single points on connected points. Then using rest node to get the current state as an attribute called rest, and then flatten out to make it like a flat surface. But because I have the rest, I can make each point back to the original state by accessing to the rest, okay, which could be useful. Okay, especially if you want to create a random value for each point, but you don't want to create a different value for a connected points. And if you want to, if the point is not connected, then you want to create a different value. Then using rest as a seed makes sense. Okay, so let's do that. As I told you, if you try to create a vellum cloth out of this, then the problem is the vellum think it's all being connected, so it's gonna ignore the cut that I made by connecting this one. That's not what I want. I don't really need the bend force where there should be a hole, so I need to remove that. In order to do that, the easiest way is to just make it open, slightly make it open. Okay, geometry wise. So I could do that by using an additional point wrangle, randomly change the height of each point slightly to a y direction, and using the rest value, the rest position as a seed for the random, which means if the point is being connected, you get the same value. If the point is being separated, you get different values. So let's check. If I make a random values out of the rest positions, then apply that random values to y, get something like this, but it's a bit too noisy, so let's make it a bit smaller in terms of the movement. Okay, it's a bit hard to see what's going on, so let's raise this up a little bit more. So you see you are slightly having a little bit of openings for each cutting edges, like that, and that's the necessary things to do when you're going to create a cloth. If you have a real hole, then it's going to treat the vellum cloth, it's gonna treat it as a hole. So, and that could be really small, could be like 0.001. That's enough. Okay. All right. Now, now that I have converted into cloth, anything else that I need to do? Well, in order, the simple setup will be something like this, but in order to make it tearing or pin to some positions, then you need to add additional constraints. So let's add a pin Vellum pin or Vellum constraints, and change the constraint type to pin to target, and just pin the border points, the points which are at the border, to be pinned, to be fixed, just to test. I mean, anywhere could be pinned, but this is just a test. So I'm gonna pick the border points and gonna make those points pinned. So in order to do that, I need to know where the border is. So let's think where I can get those information. So after I have made the Y position, point position, I could use additional fuse node, which is going to reconnect all the points, fuse all the points. Then you could use a group node to see where is the border points. By enabling include by edges, unshared edges. Okay, so these are the border points. Now you can refer to those points from original point, which is before being fused. Okay, like this. You cannot just connect this to here, because if you do that, then you're gonna lose the opening. But you need to keep the points unfused in order to make those openings. So what you need to do is to transfer the border group from this point group to this point group. I'm not gonna use transfer group node because sometimes it acts unstably, not as I intended. So I'm just gonna use point wrangle, since I know what's going on here if I write it myself. So first I'm going to look for the nearest point from the second input. Then check if those near point is in the border group or not. If in point group border at npt is equal to 1, then set point group border ptnum 1. Alright. Okay, let's check. I can check it by using a color node. For the border points, let's make it red. And if the border becomes red, then successfully transfer the group. Okay, it's good, looks good. Alright. Now, currently the red surface is a bit too noisy, so let's just remove the color. I'm gonna use the color node. Yeah, just gonna reset it to white. Okay, now for the pin, I only want to create a pin for the border points, so let's make the group type the point and set the group to border. Alright, so those points is gonna be pinned, and it's not gonna move. Alright, and I guess I can start doing the test simulations at this point. So Vellum solver, And in order to do the simulations, you do need to have some forces. So I'm gonna create a obstacle like a sphere, and which is going to go through the cloth from bottom to top for a test. Right, so let's do that. I am going to create the sphere. Oops. And place it underneath the cloth. Make it big enough. Okay. Okay, somewhere on here. All right. And I'm gonna connect this to a constraint or obstacle part of the Vellum constraints. So right here. Right. Now now what I could do is to actually move those geometry, or I could move the border points by myself. Either way. Now where is it? Okay, well, in order to move the sphere or the collision or the obstacles, I guess you need to do it inside the Vellum solver in order to move it. Or you could also move the pinned points, in this case on bottom direction, by yourself. So I forgot which way I did for the example, so let me check how I did it last time. Seems like I don't really remember, but seems like I am moving the pin. No. Seems like I am moving obstacles, but okay, seems like I can move the constraints right here. I mean, it doesn't have to be inside the Vellum solver, but I can just create an expression to move the sphere here. So create a point wrangle to move the sphere. I'm just gonna say update the y by frame-based value, multiply by, I don't know, 0.01 or 0.1. Let's check. That's too slow. Alright. That might be too fast. Oh, what it's doing. Okay, so it's already creating something here. Yeah, it's good. The problem is, because I didn't set up any tiering, it's just gonna stretch and stretch forever. Yeah, it's a bit too unrealistic. So let's fix this. If you have so many stresses on specific areas, then you want to tier demesh. But for the things that I have here, it looks fine. Yeah. Okay, so to do this, you need to I think there is a lot of way to do that, but what I'm gonna use is the constraint called weld, Vellum weld. Do I have it here? Yeah, this one, Vellum weld points. This is the constraints that I'm gonna use. All right, which I saw it on the official document, so, but I'm not sure if the way that I'm using is correct or not. Okay, to set up, you need to do several, you need to change several values first. You need to make sure everything that everywhere that you want to tier has to be splitted initially. Okay? Meaning you have to split all the edges, fracture all the edges first. Even if it looks like it's connected, you need to temporarily split it before doing the simulations. So to do that, I am going to do that after making a small hole with this random. I am going to use a node called edge fracture, which is going to make each connected edge being splitted. So if I select single primitive and move it, yeah, I think I need to change the settings. Maybe I don't really need to do anything. Does it? Forgot what. Maybe it doesn't really change the number of primitive, or just changes the edge information here. But having this edge fracture, let's remove this wall point for now. And if you do the simulations, you see that every primitive is gonna fracture it instantly, like that. Okay, so this is not really what I want, but what I want is to connect the strips until it has too much stress by the collisions. Okay, so to keep those edges connected, this is where you need this weld. All right. So you need to define how strong the connection is by changing the threshold here. You need to check the threshold here, as well as this stiffness. Now I'm not gonna change the stiffness, but I'm gonna use this breaking threshold to control when it's gonna break, when it's gonna tear. Let's start off with 0.1, the default value. Let's see how it goes. Okay, looks still too weak as a glue, so let's make it 1 to see. Okay, so those places are being sticked together, so at least it's doing better than before, but it's still ripping apart pretty fast here. So let's increase this a little bit more, like 2. Now starting to get better, right? but it's a bit weird to have those square strips here, right? So, in order to fix this, or in order to have a better result than this, my tip is to increase a little bit of resolutions for these squared shape. Meaning I'm just going to add additional subdivide to this with a setup. I just want to make a clean square subdivision, so I'm gonna use open subdivide linear which will double the number of squares for each rectangle. Not the double, but it's gonna make 4 squares for each square. So the simulation cost rise up a little bit, but I think it's gonna create a little bit better result as a simulation. Let's see. It's not breaking. Oh, started to break. Yeah, so something like that. I mean, it's up to how you find it is, if it looks realistic or not. So it's up to you. Now I guess I don't want to have a gravity here. I want to consider that it is placed on top of the floor. Maybe I can add the ground. Alright. And also you can control the how do I say, the stiffness. The stiffness for the geometry, I mean the cloth, especially for the bending. If you increase the bending, then it will start to look like a paper or like a rubber-like cloth, which I would prefer to see. So let's increase this to 10,000 and again see the result. Yeah, starting to look interesting. Maybe the breaking threshold is a bit too big in this setup. Okay, well, it does what it does. If I remove the subdivide, yeah, you see how it reacts differently, so I would prefer having this one myself. Okay. Now that was pretty simple setup. Let's also try different like collisions, or let's try removing the obstacles and instead try to pull one side or two sides in opposite directions and see how it's gonna change the shape. Right. So in that case, let's create variation, shall we? I'm gonna create a parameter here. Gonna call this test type. I want to test several forces. In this case, I'm just gonna choose 0, 1. Okay, if it's equal to 0, then I want to move the collisions, I mean the obstacles, just like I did. So let's copy this and create a switch node. Paste it here. So if it's equal to 0, I'm going to use this sphere as the obstacle. If not, I'm going to use null, which means no obstacle. Right. Now, if there is no obstacle, then what I want to do is to pull the clothes in for this edge to go in this direction and this edge to go in this direction. That's what I would like to try. Okay, so let's do that. In order to do that, you need to have those groups. Currently, I have the whole border as a border group, but I only need those side edges. So I guess I need to have additional group for that. So maybe I could change the function right here and also check if the test type is equal to 0 or not. So test type copy paste the parameter that I brought from the controller node. Right, then if the test type is equal to 0, then this is the border. Okay, and if not, else if test type is equal to 1, then I just want to copy the side, D side here. So what could be the conditions? What could be the additional conditions here? I mean, I could still use several stuff here. Now I probably need to have additional conditions inside here in order to remove those Z positive and Z negative edges. Now probably I could use the boundary box information for that. So get the minimum and maximum information. Right, then if point P dot Z subtract by min dot Z absolute is smaller than small number, or wait a minute, maybe I can go like this, larger, and do the same things for the maximum value. Like that. Okay, so let's check. Let's change the test type to 1, and let's color with the border with the red. Okay, so now I am seeing that all those edges on the side, it's being selected as a border. Now this point is not being selected, but that's fine, I guess. Yeah, it's not a big problem. Okay, so that's good. Let's remove this back to white. And now let's see what's happening here. So right now obstacle is not moving, so I think nothing is gonna happen here. So next thing I would like to do is to move those border points on opposite direction. So this edge goes to this direction, this edge goes to this direction. Alright, so I can do that inside here. I could use a solver. I'm gonna use the constraint geometry node, and this is the this is where you can control the input geometry. So I'm going to use the point wrangle for the border points. Doesn't show up. Huh. Okay, let me make sure if I have the border points coming from this first input. Let's check the geometry spreadsheet, and okay, yeah, I do have these. So I want access to those points and move those point position inside the subsolver and connect it to here. Okay, so hopefully I'm accessing to the border points. Do I have it? Yeah, I do have it. Now let's get the current point position. And let's get the sign value of in which direction was it? So I wanted to move in these direction. That is x direction, right? So, and since it is placed on a center, meaning 0, 0, 0, the left edge has a negative x value, the right edge has the positive x value. So with that information, I can use a sign function to get either -1 and +1 out of .x. So if it is negative, you get -1. If it's positive, you get +1 using sign. Now you can use this information to update the point position for the border to s multiplied by small moving value. So if it is negative, then you're moving to the negative direction. Okay, something weird. Let's see what's gonna happen. And it's positive, it's going to move in positive direction. That's weird. Okay, well, let's see what happens. Well, obviously something is wrong. Maybe the group has been messed up because of this subdivide node. Yeah, I think that's why. So now if that's the case, I need to transfer this later. Okay, so I need to transfer this right here. Okay, let's check. Nope, it's not working. Yep, it's not working. Let's see. So I have these. Oh, I see. So because I'm using new points, for those points I cannot really find the nearest point because this one is not coming from the subdivide. So actually I need to create a border from the subdivide geometry, which is this one. Yeah, and that should solve the problem. Yep. Okay. Alright. So let's see how this goes. Okay, still seeing some weird triangular shape here. Let's see how it's gonna. Okay, well, it does work. Looks like an accordion. And if you keep pulling, it should tear up at some point. Maybe the stress is a bit too, the breaking threshold is a bit too big. It's pretty strong. Starting to see some rips. Okay, well, that took time. Maybe I could update the threshold to 1. Yeah. Okay. Alright, that's good. Why did you use subsolver instead of something like pop wrangle to move the border points within Vellum solver? Well, nothing reasonable. I mean, I think it's okay to use pop solver as well. I mean, pop wrangle as well. There's no meaning why I use subsolver, but a lot of time I use subsolver in order to change the constraints. So if I want to change the constraints as well at some point, then maybe having subsolver could be more flexible, and that's the only reason. So it doesn't really need to be subsolver for at all. I mean, it's up to your choice for sure. Yep. So and if I switch this back to a test type 0, let's see if it still works. Oh wait, now I need to change this to work only on test type equal to 1. So it's a question of habit for more advanced setups. Yeah, it's kind of my habit, so no need to follow my way for sure. I'm not sure which way is better. It's just too used to me. I mean, I'm getting too used to using solver, so that's kind of why. Okay, let me copy this test type here. Okay, let's try this again. If I have a test type equal to... Oh, wait a minute. I made a mistake. I should connect it like this. Okay, so seems to work. Alright, so for this specific tutorial, this is it for tonight. Now from now on, maybe I could try to test with some other types of cutting lines, which I haven't tried, so I'm not sure how I will do it. Just gonna try it. Try to figure out in this hour. But the things that I wanted to tell you is until here. And let me know if you have any questions for this one. I think it's pretty simple compared to the other tutorial live, so it's nothing special, but and not so many parameters, just the size, number of holes. What else? Yeah, not so many parameters here. This is just a simple idea how you could use a Vellum to do the tearing simulation. Okay, so and I am going to upload the file that I have created to a GitHub and paste the URL to the video description page of this YouTube live stream, so you can download it later to check it out. Now, so that's it for today. Now, if you do still have some time, I'm going to try creating some custom setup for custom cutting lines and see how that works. I mean, the way that I created this setup is pretty clean because you know the final shape. I could make this kind of a mesh structure because I knew how it's gonna be ended up. So that was easy, but if I make a custom cutting lines, then you don't really know what's the final result. You can't really create a clean mesh structures like these, right? So that's the problem, but that's where you would appreciate the proceduralism, I guess, and that's what I would like to try now, if you don't mind. So if you are only interested in this kind of shape, then that's it for today. If you are still interested in some other procedural shape, then you could still watch, but you could still keep watching, but I'm not gonna guarantee you if it's gonna work or not. Just gonna test it out. All right. So let's do this. All right. So for custom cutting lines, I'm going to start with the original grid size, where the rows and columns are equal to 2. So from here now on, I don't have any reference, so just going to do this with my imagination. Right, so finger crossed. Alright, so let's first create the similar shape. It doesn't really look similar, does it? Huh. Seems like I am misunderstood the size here. Maybe the calculation is wrong. Where was it? Here. Yeah, I think I needed to multiply this by 2. Right. So now it's similar, and now it's looks like it's the other way around. Okay. Let's see if the result have changed. I mean, anyway, I could change the size here. Yep, so it works. It's fine. Okay, so first thing I would like to do here for the custom cutting lines, you need to do a cutting line for sure. Yeah, some pattern. So yeah, let's make that. How do I make that? I mean, it could be a curved lines, not just straight lines, but curved lines might be interesting. So shall we try that? Just gonna draw one custom curve by myself. Oops, not that. Custom curve using curve polygon. Some simple arc-like curve. Okay. Oop. Place it inside a geometry node. Now that looks a bit too big. Now I'm going to resample this with the subdivide. Make it smooth. And I don't want to have too much points, because the number of points you have, you get the final mesh to have tons of points as well. So I would like to reduce those point number as much as possible. Somewhere around here, maybe. Yeah, this is decent, I guess. And now let's also make this a bit smaller. It's a bit too big. Should I do it here? Oh well, that's a bit too... I don't really like using edit. Okay, what I'm gonna do, using point wrangle, and I'm going to scale this referring to the bounding geometry. So getting the bounding size from the second input, boundings get b-box size. Then first of all, I'm going to stretch this original shape, which is going to fit into this square. Right, so to do that, you also need the center position. Right, that's the target center, that's the target size. You also need the source size and the source center. Source center. Right, now first of all, you want to move this to the center of this grid, or before doing that, I want to move this to the 0, 0, 0 position. So let's move that by subtracting by the source center. All right, then scale it up by the target size divided by source size. Then move this back to the target center. Alright. Now as a result, it should fit inside the square. And I'm going to create a repetitive pattern from here now on. Okay, so let's do that. And to do that, maybe I could just divide this grid into several grids like that. Right. And for each point, I could copy this original curve with the specific size and direction. That could just be a cutting line. Right. Okay, so let's do that. For the size, for the number of rows and columns, maybe I could use this information here. Yeah. And have it here. Paste it here. Now this is for the rows, so for the columns, I want to make it square as possible, so I need to make an expression. So if this is for the rows, now this will be related to the y size. So if you want to have a column size, then what you need to do is to multiply this. Divide this by y size and multiply by the size x. Let's see. And hopefully this will become square as possible. So if I change this, yep, looks good. Let's make with the small number of points for now. Okay. Now, for each point, I need to decide the size of the curve. So that's going to be defined using p-scale. And also, I don't really need to place each curve on every point, but could be on, I don't know, checker point position. Yeah. So let's think how I should do that. First of all, need to set the size for. So what I want to know is the size of each edge, which can be calculated using those expressions, size x divided by column, or size y divided by rows. So I could just copy this value here. And also the rows. this one. Right here. Okay, and then check what's the size for the edge. Edge size is equal to y size divided by rows. Now let's see. Currently the rows is equal to 10, so 1, 2, 3, 4, 5, 6, 7, 8. Actually, I have only 9 edges here, so probably I need to do the subtraction by 1 for this row to have the exact value for each edge. Now, now that I have the size here, I can set it as a p-scale. Alright, then using copy 2 points to the direction is wrong, so let's change the normal direction, or the up vector. The up vector for the point is 0, 1, 0, and for the normal 0, 0, 1, not sure. And is that it? Okay. Now still looks really big. Okay, let's see. One thing I missed is dividing this E size by the total scale for the width or for the height. Actually, yeah, I kind of don't want to use p-scale, but I want to use scale, vector scale for this one, because the size for the x and y is gonna differ. Right, so for the x direction, x size, it's gonna be edge size divided by, or gotta call this x scale, e size by the get b box size dot x. Okay. That's the x direction, right? Right. Now for the y scale, that's e size divided by z. Now you could use x scale 1 y scale. Alright, there you go. Okay, and now that doesn't look nice, so I'm going to flip or change the size from here a little bit. I could give additional scaling to this one. Additional offset scale. To make it slightly smaller. Yeah. And I mean, I could just try with these for a test, but I want to have a bit more nicer curve profile. So let's try to make the checker pattern, like checker position curve, to flip 180 degrees. Yeah, that'll be nice. So let's do that. In order to do that, you need to know the index number for the point in x direction and y direction. Right. So in x direction it goes x 0, 1, 2, 3, 4, 5, 6 and go back to 7 on the next row. And the number of rows and columns are related to that. Okay, so I could copy this and get column. Right, and a x number could be a point number modulus column. Let's check. I'm gonna create an x attribute. Hello from Mexico. Nice. I love Mexico. X, let's check the x. Okay, so the x number 0, 1, 2, 3, 0, 1, 2. Okay, looks good. So let's also create a y number. That is pt number divided by column and using 4. That should create a y number. Let's check this again. Okay, so 0, 1, 2, 3. Yeah, looks like it's working. Alright, so now you have x and y direction number. You can use these to set the direction for the curve. If it is on the checker positions, then you want to rotate 180 degrees. So if x modulus 2 equal to 0 and if y modulus 2 equal to 0, then let's see where that is by coloring it. Okay, now currently I am missing the normal, so it's all black. I'm gonna check the color temporarily adding. Okay, so currently I have those points colored. I also want to make these points colored as well, so that it'll become checker points. So I need additional conditions here, or x modulus 2 is equal to 1 and y modulus 2 is equal to 1. There you go. It looks like a diagonal line, but actually you're only having the color at the checker position. Yep. Okay, that looks good. Now for these positions I want to rotate by 90 degrees, and to do that you need to change these up and normal direction, right? So you don't really need to change the up directions, but you could change the normal direction, I guess. So if it's at the checker positions, set this to 0, 0, 1. If not, set this to 0, 0, -1 and see what happens. There you go. Well, not interesting. Let's change this to something else. Well, how do I okay, well, a little bit interesting, but still not. Maybe the original curve is not that good. What if I flip here? Doesn't make any change. Oh well, I'm just gonna try with these. Okay, because it's just want to test it out. So now that I have curve, let's try to create a cut out of this curve onto a grid. So maybe I can use this grid, and before cutting I'm going to dissolve all the inner edges because I don't want to have those grid to add the cut lines. So let's make it like a square, and let's also use a primitive properties, or no, not this one. What was it called? Facet. Currently I have points on these edges. I want to also dissolve that. So I'm going to check remove inline points, which will remove all the inner points. Now somehow I want to create the remesh geometry, which is going to have these curves as a part of the remeshing. And how do we do that? Probably I need to use remesh, and I want to have these points as the constraints. Now let's see if I could extrude, poly extrude these upward. Make the normal direction to upper direction. Then use that point normal to create a wall-like shape. Then move this a little bit down. Create a boolean between the clean grid shape and the extruded surface. Both surface and yeah, using subtract is fine, and you do get these edges now. That's good. What else do I have? Intersect, nope. Subtract, yep. Shatter, yep. Shatter also works. Seam, nope. So I'll just use subtract. Well, subtract might not work if I make the curve closed curve, so it only works with the open curve, I guess. But for now it's okay. Now I can connect this to a remesh, and I want to keep the original points. So how do I do that? I want to make those points as a seam right? So there should be, okay, use input points. Oh, no, that's not it. So there's a hard edge group here, so maybe I can specify those edges as a hard edge, right? So shall we do that? I mean, I can just I can use, well, is there any thing about the edges? There is no wrangle for edges, I think, so it's a bit hard to control, especially the edge group. Yeah, so in order to specify the edge group, you need to use a node way or using point or primitive wrangle, right? So let's see if I want to use the group node or the edge. And I want to ignore those edges here. I don't want to make it as a hard edge. So I mean, I guess I could, but let's see if I don't want to. Then what's... no idea. Let's just do it a wrangle way. Move. So I have this information here, and I have this those geometry here. What I could use is either point wrangle, maybe point wrangle, yeah. And in order to specify the edge, you can get the neighbor points, and the connection between the neighbor points will become the edge. And that's how you also specify the edge group. The number of the point number of yourself and the point number of your neighbor. Okay. So let's get the neighbor points, which could be multiple numbers. Right, then search for all the neighbors. Then get the point position of the neighbor point. Now, if the neighbor point position and your current point positions is touching to this wall, then that means you want to make it as a hard edge. If it is not touching with these walls, then you don't want to make it as a hard edge. So that's the condition you want to make. So let's do that. So you want to calculate the distance to this wall here. So distance 1, XYZ dist, and pause, and distance 2, XYZ distance, using your own distance. Okay, and if the distance 1 and distance 2 is small enough, which means it's touching the edge, that's where you want to specify the edge to be a hard edge. Okay, doesn't look really smart, but well, there might be a node to do that, but I'm not sure what that is. Oh, I have a comment. I believe you could automatically compute your edge group with the booleans A, B, C parameter. Ah, okay, yeah. You're right. You're right, there is those group. Oh yeah. So probably this one. AB seams. Let's check. It's a bit hard to check the edge group, but one of the way I would do is to use color node. I mean, still it's the point, but well, probably it's been selected correctly for this heavy seams. I don't think this edge has been created as a AB seam. I believe. How do I check it? Oh wow. Let's see. I'm just gonna check it like hardcore way. You can check with the group node. Set it to edges with base group apps. Oh, okay. You could do that. Thank you. Edges. Maybe seams. Seems like this edge has also been selected. Not sure if that's the case. Not group name. Oh yeah, this one here. Sorry. Oh yeah, there you go. Thank you. Yeah, it worked. And then that's much better. Thank you very much. So now I can use this as a hard edge. Does it keep the edge shape? Let's see with and without it. If I decrease this, okay, I do see the shape of the curve somehow. Yeah, it is being preserving the edge, so that's good. Alright, that is good. And that's also where I want to make it an open position, so that's the next thing I need to do. I need to unfuse those points. Yeah, but I do still want to connect those part. Only want to create the split onto this part and this part. So okay, that's another question. So how do we do this? Well, after creating the remesh, well, I could use the point wrangle and see which point is touching the wall. And let's call this open. Preparation for the open. Yep. First, calculate the distance. And if the distance is close enough to 0, then that's where you want to open, cut. Right, let's see, let's check. Okay, now in order to make those places open, I think you could use edge cusp or something. Yeah, let's see. Do I still have that group after remesh? Okay, so previously I did after remesh. Nope. Seems the edge group is missing. Oh, but I have this one. Let's check if this is what I want. Alright. So I guess I could use this to cusp. And see, let's see what happens. If I could make it opened. Alright, so what I want to do is to select one of the points on these cut lines, somewhere around here, and if I can make it opened. Alright, okay, looks like it's working. Now I need some offset, just like I did here. Go up and down. And for this, what can I use? Well, since I don't have a rest position informations, I would just gonna use a point number to move up and down. It's not perfect, but it'll do the job, I guess. So I'm just gonna copy this one here, and instead of using rest, I'm going to try to use a PT number. It's a bit hard to see, so raise this value up. Okay. Now it's going up and down, but I guess that's fine. The only reason I want to make it open is to create a Vellum constraint, so let's make it 0.01. And the rest is pretty much the same, I guess. Yeah. So this is where I can use a switch node. Do I need a subdivide? I don't think so. But I do need to set the border, so this is where I can switch, I think. Maybe not. Is it? Now that I think of, I need to make this flattened out, just to make sure that the fuse will always connect all the whole openings. Right. Okay, and let's see what's going on here. So hopefully this goes well. And let's check the border. Okay, so the border has been fixed. some. Okay. And having edge fracture. The rest is pretty much the same, and let's see how it goes. And I am missing the bowl, so let's move this. Or move the whole geometry to the center, maybe. This is not on the center, is it? This one. This is on the center. Maybe this one is not on the center. Yeah. So I'll just use a transform node here to move the whole stuff to the center. Just X and Z. Alright. Should do it. And for the sphere, I'm going to move this to a corresponding position. Alright. Okay, let's test. Finger crossed in. How does it go? Alright, not bad. I might need more resolutions. I might need more curves. Okay, let's have like 30 or 25 and high res. That might be a bit too high, not sure. Let's check. Alright, so this has been proved that any curve can be used for this kind of simulations. Yeah, I guess I'm satisfied with the result. Yeah, funny, it's not breaking yet. Okay, start to break. Huh. Looks like a rubber. Right, so any curve, any cutting line can be used now. Okay, not sure if this is used for anything, but it's fun. It's fun. Yeah. Laughing. Okay, that's it. That's it for today, I think. It's already 3 a.m. so I guess it's time to finish the live. Let me know if you have any questions. If not, I'll end the live. Let me just organize the parameter a little bit and I'll end the live. Okay, this was the check. You needed to offset the points in Y for Vellum configured to make sure they are not welded in the sim. But why, with the edge fracture, did it disconnect the faces regardless? With the edge fractures, did it disconnect the faces regardless? The edge fracture only. The edge fracture creates the special, I guess, special edge group for a vellum, which can only be collapsed or ripped by the vellum shape, but this doesn't really split the shape. It just create a small. It just convert each edge to some weak glue edge, which only works on Vellum. Seems like it only works on Vellum. Geometrically, all the mesh is still being connected even if you have this. except for these opens one. And yeah, and I needed to make this random node to make those to make sure that these are having openings. If not, I'll show you what happens if I don't have this one. Then all the edge is being connected together when you have converted it with the Vellum cloth. And if you play it, you don't get any openings. So that's how Vellum seems to work. So it's kind of a workaround in order to make an opening. You do need a little bit of offset on y directions. Just have it here. I mean, if I don't really need it, then I don't really want to do this, but for now, from what I know, seems I need it. There might be a way you don't need this kind of process, but not sure how. So this is my way. Yeah, let's see how it works. Okay, and you could go back to the curve, change the shape. Oops. See how it makes it different. Let's see. Say hi if I have a S-like shape. No. Huh. I don't like this. And let's make this whole curve a little bit smaller. Where is it? Where did I? Yeah, here. Huh. Oh well, I guess that's fine. Maybe I might need to have an option in order to change the direction here. Maybe having some parameters to change these would be a good idea. Okay. Okay, let's try out these. See what happens. All right. Okay. Yeah. And if I pull it to the side, yep. I guess I could use this setup to try several simulations. I'm not sure how realistic it is, but at least as a first demo. Ooh, it looks like a pizza. All right. Okay, let me organize the parameters a little bit more, and I'll finish this live. Appreciate what you do. You have helped me in my career for both game and film. Thank you for saying that. I'm glad things that I do helped people in some way. So let's create a toggle to define whether you want to use a freeform curve or not. Just let's say free curve. If it is true, then use the left one. If it is false, use the right one. Regular mesh, free curve, cut. Copy this, paste it here. So if it is true, I want to use the left one, so let's change the order here. Right. Now for the parameters, you have these curve, sample. I mean, I'm not gonna parameterize all those stuff here because it's all depends on anybody who use it. So just gonna keep it as it is. And for the lengths, what's this? This is to resize. Yeah. And this is the point scale. Yeah, so it's a parameter you can change. And let's see, what can I do with these order here? Maybe I could just make it as a vector parameter, maybe. CHB or angle, maybe. Yeah. Maybe I can, so that I can just use one parameter. Alright, I think that's better. So in order to use an angle, I could get an angle from the parameter. It could be just from 0 to 1. Yeah. And I'm just going to multiply by pi multiplied by 2. Yeah. Which will become 0 to 360 degrees. Then I could create a rotational matrix here. And rotate it by the angle using y-axis. Actually, I need two angles. One is one for the checker point and one for the other checker points. So alright, now this is using angle 2. And finally you can rotate the x vector value with the matrix. Right. Okay, that should do it. So if you're having a same value, same angle, you're having every curve to be placed in a similar direction, but you could change the checker point position by your choice. Alright, Now that looks a bit more interesting. Yeah. Let's see. Change this to free curve. Alright, not to that direction. Cool. Okay, not bad. So I probably want to show the parameters only when I check this free curve turned on. Something like the resolutions or what else? These resample curve and so on, maybe. Yeah, maybe just the resolution is fine. Yeah, let's just show this parameter only when the free curve toggle is on. Yeah. So let's go to the edit parameter interface, and I'm gonna bring the remesh target size just under the free curve. Then I only want to show this. Mesh res. I want to show this only if the free curve is turned on, so you can do that by having some constraints here. So hide when mesh, no, free curve is equal to 0. Does this work? Nope, doesn't work. Forgot how to write the do I need it semicolon here? Nope. Totally forgot how to write this. Let me see. Free curve equal to 0. Oh, do I need a space here? Let me see. Ah, thank you. Thank you again. Now this works. Okay, that's it. I think I now have everything I wanted to test out for today. Alright, that's it. Thank you very much for watching, and as always, I'm going to upload the files and you can download it from the video description page. Yeah. I'm also doing Patreon, so if you could support me on those Patreon page, that would also be great. But everything I do can be watched for free and downloaded for free, so feel free to check it out. Okay, that's it. Thank you very much. I'm looking forward to do next week as well. If you could join it, that would be great. Okay, that's it. Good night, and see you next week. Yeah, and the next week I probably do some procedural animation stuff, I think. Okay. Night. And thank you everybody for joining and all the comments. Appreciate it. And I learned a lot from you guys.